Okay, so again, I have a vector equation here. I want to figure out how many solutions it has. If there are finitely many, I will express the set using our set notation. So here we have our vector equation. I want to start by writing this as an augmented matrix. As usual, the vectors in our vector equation become the columns of our augmented matrix. Okay, so I'll have my augmented matrix going from top to bottom. We have 4, 3, 5, and 36. Then my second column, 1, 1, 0, 6. And then 0, 1, -4, -9. The vertical line, which separates the vectors that are being multiplied by my variables from the constant one that it's set equal to. So then I have this constant values of 10, 10, 3, and 69. Okay, so there's my original augmented matrix. I want to row reduce this using my calculator, so I'll say RREF to indicate that I'm computing the reduced row echelon form of this matrix, and I want to write my result. So when I row reduce this, I get 1, 0, 0, my vertical line, and then 3. And then in the second row, I get 0, 1, 0, and then -2. And then finally 0, 0, 1, 3, and then 0, 0, 0, 0. Okay, now I want to translate this back into a system of equations. So in the first row, x1 equals 3. Then in the second row, x2 equals -2. Then in the third row, x3 equals 3. And then in the fourth row, 0 equals 0. Okay, so let's observe what's happening here. 0 equals 0 just means there's not a contradiction. There's no contradictions here like 0 equals 1. So that means we have at least one solution. We either have one solution or infinitely many. What I also observe is that my variables are, how I'll describe them, is isolated. I get x1 equals something, x2 equals something, x3 equals something. That tells me, since there are no contradictions and my variables are isolated, that I have one solution. So we have one solution. And it's precisely when x1 equals 3, x2 equals -2, and x3 equals 3. Now I want to write that as a vector. So I want to describe the solution using set notation. So I'll have the set containing just one vector with 3, -2, and 3. Okay, so this is the solution set, the set containing this one vector with x1 equals 3, x2 equals -2, and x3 equals 3. That space, that set with just one thing in it, that is our solution. So again, we started with a vector equation, we put it into a matrix, we row reduced, we interpreted that, we found we had one solution, and then we described the set using our set notation.